Talking. He's also... Hello? Can you hear me now? Hello, testing, 1, 2, 3. I can yell louder if that's any better. Okay, Philip Lindsay, also known as a follower from rancidbacon.com.
Okay, good afternoon everybody. I'm going to start with a pop quiz, so I hope you've all prepared for it. How many people here have done some development with Android and Arduino? Okay, about half a dozen. How about people who've done Android development? Oh, I'm sorry to hear that, okay. And how about Arduino development? Yeah, nice. And how about people that have done development with neither Arduino or Android? So we've still got a wee way to go yet then. If that's the case, I will give you an overview of the Android and Arduino side of things. Android, mobile operating system, to varying degrees open source or free software, yeah, it's probably on maybe half the phones in this room, I don't know. But you can also read Wikipedia to find out more. Arduino is a electronic prototyping platform, or as they call it, an open source electronic prototyping platform. Yeah, John will remember that, this historic occasion. This was the first Arduino project I ever worked on with John and another guy. And basically it was a remote control car that you could use a Nokia 700 and dial up a distance that you wanted to go. It would transmit the distance over Bluetooth, and then the car would move forward. Well, it would move forward if you kind of gave it a little push with your hand, because there was so much batteries and other things on it that it was a little underpowered. So this also is a helpful reminder that if your first Arduino project doesn't look as slick as some of the stuff you've seen out there, this is how everything starts off anyway. So basically, the idea is that it makes it easier for non-technical people or technical people without hardware experience to get started with producing hardware. And there's multiple form factors. So at the top we have a lily pad, which is designed to be sewn into clothing and other things like that. We've got a smaller size, so if you cramp for space. And then we also have on the other side the Arduino Mega, where if you need more RAM or connections or flash, you can store it there. One of the other cool things is that it's expandable with shields. So basically you can put a shield on the top and stack them up so that if you want some additional functionality, you can benefit from that. So this particular shield is a USB host shield, coincidentally. So again, Arduino is open. The board designs you can download and create your own. The IDE is written in Java and is GPL licensed and actually is based on a project called Processing. And then underneath it uses AVR GCC, which is obviously based on the standard GCC compiler chain, but it also has the benefit that if at some point you say, oh, want to drop down to a lower level, you don't have to kind of relearn everything, you just carry on down. So the language is, it's called the Arduino language, but in fact it's basically a subset of C and C++, but nobody says that because we don't want to scare anybody off. But the cool thing is that you can learn as you go, and then everything that you learn is still applicable down the road. So you'll think, well, that sounds pretty cool. I've got an Android phone and I think I can learn some of this Arduino stuff. Why on earth would I want to connect the two of them together? So you can do things like customize your phone hardware. So you might say, hey, I've got this awesome new idea for making it so that whenever I tap my foot, it answers the phone call so I don't have to wave my hands around to access it. Or you could go the other way and say, hey, I want to take something that's normally from my phone and display it in some other way. So for example, you can also take the functionality of the phone, so GPS or accelerometer, and provide that to your Arduino. So instead of having to buy an accessory shield, you can actually just use your phone as a super duper accessory shield. Or you might have an idea for something like a custom dock so that when you come home, you plug your phone in and it charges it and does something else to your home as well. So the next question is, how do we connect these two things together? Well, until sort of midway through last year, there were a number of unofficial solutions for connecting things together. One of them was Arduino that still exists and allows you to connect the Arduino using Bluetooth, and so you'd need a Bluetooth shield on your Arduino and then use the Bluetooth functionality of your phone. You could also use a SparkFun Yo-Yo, which was designed to use with a debug functionality on the phone, so you had to turn on debugging, but then it would allow you to communicate with it. And then, of course, you also had the option to use Ethernet over Wi-Fi or wired. But then at Google I/O last year, Google announced the Android Open Accessory Protocol, which, if you've been at John's session, he gave a overview of. So basically, it meant that you could create new accessories and attach them to your phone or tablet without having to go through designing all of the hardware yourself. So, of course, you're thinking, okay, big announcement at Google. They'll have some really great example peripherals, which they did. One of them was a giant labyrinth game, which you could use a tablet to control a bowling ball as it was being rolled around this huge labyrinth game. Or you could connect to an exercise bike and have an exercise bike as your peripheral, and as you biked along, it would keep track of the various statistics. And then not long afterwards, Harman announced that they were going to support some of this in their sound systems related to dashboard control and that sort of thing. And I saw this stuff and I thought, hey, there's some kind of cool stuff here. And I happened to have a shield that was compatible with the software. And so I thought, I should try and build something as well. And the project ended up getting featured on the Make blog and on Hackaday and on some Russian blog that called Crazy Dev, and apparently I'm a handyman, so that was good. And then it also made it to Engadget, which was the first time I'd ever had a project on Engadget, which was kind of educational. It led to comments like these. And these. So you may be saying to yourself, well, what's this project that's kind of causes so much consternation to the esteemed readers of Engadget? And it is, in fact, the dual display Nexus 1. So I know that lots of people have a problem where if you're playing a game full screen on your phone or some other full screen app, when you have a message come through, you don't know who the message is from. And if you, maybe you're playing a game and you lose track of time because you can't see the time on your phone, and then you get late for your appointment. So the dual screen Nexus 1 solves this problem. So if we apply some power, so this is the dual screen accessory, and when we connect it to our phone, you'll notice the hardware has a couple of kinks in it at the moment. So we connect it to our phone, and when it starts up, it lets us know at the top that we've got an accessory connected, and then nothing more happens. Except on the accessory, we now have a clock. So if we go into a game, I'm partial to Scooter Hero, and start playing. Hopefully Mark can now send me a text. while nothing has appeared on my phone, underneath on the dual display, it now shows me who's sent me a text and the first few words of it, so I can decide whether or not I want to answer it. And seeing Mark's been extremely helpful to me over the last couple of days, I will indeed say, hi Mark. So this is the dual display Nexus 1. And so inside the box, we have an LCD proto shield that I put together, which helps me use less pins, and then also Arduino Mega ADK board, which is this piece along the bottom. So, and they're just stacked up like so. So that's the dual display Nexus 1. Not available at stores yet, but I am taking orders if you're interested.
Making a sandwich.
Yeah. So, that's very good. So, Android Open Accessory Protocols, we've seen an example of it. How do they actually work? Well, it's USB based, but it's a little bit odd. Basically, we'll get into some of the details, but because of the way that there were existing hardware restrictions, so lots of phones, most Android phones, when they were released, wouldn't have USB host support. Some tablets did have it, but they weren't very common. So Google was wanting to find a way to make this technology work with existing phones without requiring hardware manufacturers to change what they were already doing. And part of the Android spec required that the phones had to support USB and acting as a device, so they knew that they could rely on that. One of the other big benefits is that it's officially sanctioned. So there were existing solutions, but none of them had the support of Google as an actual part of the Android platform. And then also, unlike some other phones, operating systems, you didn't actually have to get certification for your hardware. You could make something and then connect it and then sell it if you wanted to. The hardware is open. It's based on the Arduino and the reference platform, so they were building on existing technology. And the circuit board reference designs were available as well. So this led to a large number of different companies and individuals making their own little twist on the ADK board. And then also, again, on the software side of it, they made use of existing libraries and built on top of that rather than doing everything themselves. So in terms of the communication aspect of it, with standard USB, you have a host and you have a device. So normally you'd have your PC and then you'd have an accessory of some sort. So it might be a mouse or a flash USB stick or something like that. So if you have an Android device, when you connect it to your computer, it would appear as a mass storage device, and that would allow you to transfer things towards the phone. And in this scenario, the device is an accessory. Now, you would think that if you were going to provide an accessory to your phone, then the accessory would be an accessory and the phone would be the host. But that's not actually the case when you use the Open Accessory Protocol. The accessory becomes the host because it needs to have the intelligence to interact with the phone, and because the phones didn't have the host capability, they couldn't magically make that appear in hardware. So you're in the weird situation where the accessory is actually taking control of the communication between them. Which also brings with it the need to actually have the accessory power the device, because for USB host to work, well, the spec says the host must provide power to the accessory. This, as John noted, there are ways around it, but at the moment it means that the biggest consequence of this is that sort of if you want to have a device that you take around with you as an accessory, then you need to provide some sort of power with it. Or if you've got a dock, then you'll be providing power anyway, so it's not sort of a big issue. And because of this, I think sort of docks are the easiest way to get started because you don't have to worry about the power. There is existing technology called USB on the go, which was designed specifically for this, for a scenario where you had two battery-powered devices and neither one of them had to act as host. Google, in their wisdom, chose not to support that. I don't know whether that's because the existing phones didn't support it and so it didn't actually solve their problem or not. They have said that they're wanting to work around it in the future, but it's been nearly a year and there hasn't been any more sort of comment on the technology. So Google sort of released the initial designs and released the code, but then sort of haven't made any more comment on those things. So sort of how obviously supported it will be in the future sort of remains to be seen. Google's a bit of a black box on that case. So you're thinking, this looks cool, I want to try some of this stuff out. This slide is as true now as it was nearly a year ago. This is still quite early days for the technology, and there's hope for things to sort of improve a bit. People are starting to document things in a slightly better way. But it is very much sort of, you need to try things and see if they're going to work for you. So with the original release of the Open Accessory Protocol, it's supported in Android 3.1 and above, which was used on tablets, and Android 2.3.4 and above. It's still an optional feature, so that means it is possible for a phone to have 2.3 or 0.4, but for the phone manufacturer to say, well, we're not actually providing this this technology. As far as I know, it should also be supported in Ice Cream Sandwich. Then in terms of the phone hardware, when it was released, it supported the Nexus 1 phone, which is what I'm using here. It supported the Nexus S phone and the Motorola Zoom tablet. Since the release, I've tried it with an HTC Flyer, and that worked okay. And I think now there's a lot more sort of probably hardware released in the last maybe sort of 3 months or so is more likely to support it. But again, you need to kind of check to see whether or not a particular piece of hardware will support the Open Accessory Protocol. You do have additional options. If you've got a phone and you want to root it, then I think some of the more recent versions of the custom ROMs do have support for it as well, so you can try that out. The other side of the equation in terms of how you connect your Arduino and provide the hardware support, there's a lot more options. The original Google Android ADK board was basically a custom-made board by a company in Japan, and they were about $300 or $400 because they were really limited run hardware. So as soon as the stuff was released, other companies started producing boards based on it. There were also, because it was based on existing technology, there was already boards out in the marketplace that would actually support it with a little bit of changes. So I had a SparkFun USB host shield, and with a little bit of modification to the library, that was able to work. The SparkFun USB host shield was itself based on the Circuits at Home USB host shield, and this was created by the developer of the USB host library. So this shield was supported first by the library, and then other boards were built to the same sort of specification. The Arduino dev team themselves released a product that supported it, the Arduino Mega ADK. So this is the same as an Arduino Mega, except it has the USB host functionality on the board as well. So you've got a bunch more memory and stuff because it's the Mega. And then there's a whole bunch of other ones that have different sort of unique takes on the board. So the demos that I'm using here, I don't think any one demo uses the same board as another one, including the Freetronics USB Droid, which you may be familiar with, the Freetronics company. So there was a number of libraries that you needed to support it. The Android Accessory Library, which was created by Google, and then the USB Host Shield Library, which was created by Circuits at Home. Now, there were some incompatibilities between different versions of the library. That's slowly starting to get a little bit better, and hopefully within the next couple of months, there'll be sort of a single download thing that you can download and have everything working at once. The code that I've got running on most of these things, I've been using Arduino 0022. As John mentioned, someone else has released a 1.0 compatible version. I have also got a 1.0 compatible version. I haven't yet uploaded to Git, but it'll get there eventually. So now you're going, okay, we've got the hardware sorted. I've seen the stuff, the demos of things. You know, I've seen John's demos. looks really cool. I'm a little bit apprehensive about maybe writing the Android side of the code. It's Java, maybe I haven't had much experience with it. So I'll go over some of the steps that you need to go through to write the Android application side of it. Actually, no, I wouldn't do that to you because it's actually kind of a major pain in the butt. I wrote the Nexus 1 display using the Android app, and it's if you're used to programming with Java and Android, then you'll probably, it'll just fit into that paradigm. But if you're coming from the position where the only coding that you've done is from the Arduino side, then it's quite a lot to deal with Eclipse, then deal with the SDKs for the different versions of Android, and the style of sort of indirection. And there's not a lot of example code out there. Basically, there was what Google released, and everything else is kind of based on that. And they were, supporting phones and tablets and multiple orientations and sort of like multiple layers of indirection. So it was quite a lot to be used, kind of learning a new technology and also trying to get your own code working. So I was kind of thinking, well, this is going to be a pain for people that only have Arduino background. Maybe there's some way to make it simpler for them, which led to the development of Handbag for Android. It is called Handbag, of course, because it helps you accessorize your phone. So the key thing with Handbag is that you can write and create Android accessories without writing any Android code. So you can achieve this by installing the Handbag app on your device. So there's one app for as many accessories as there can be. And then the key thing is that you actually create the user interface and functionality in your Arduino sketch. So you define how you want your user interface to look. So you'll say something like, I want to have a button, and then I want to have a text box, and then I want to have a label. And when you connect to your phone, then the Arduino will upload the user interface to the phone, and then when you interact with the buttons, those messages get sent back to your Arduino sketch, and you configure it by having a callback. So you might say, when this button is pressed, I want to call this Arduino function, and then the Arduino function might toggle the state of an LED. But the key thing is that instead of having to have both your Arduino code working and also develop Android code at the same time, you can just focus on the Arduino sketch. So even if you can write Android code and you're quite happy doing it, you can still use Handbag to sort of focus on one side of the task at a time. And then once you've got it working with Handbag, you can go, okay, we've got the main guts of it working, now we can work on an Android app. Or if you don't want to write Java, then you can just leave it as your accessory. So let's do another demo, or another couple of demos. So this is a multimeter demo, because you can never have too many tools. So we have our phone, and then we have our extremely sophisticated multimeter. So what happens is when we plug some power in, and then we plug our phone in, so we've plugged it in. The accessory is said to the phone, hey, I'm a Handbag accessory, and then the Handbag app is launched. Then the Arduino has said, okay, I want to have a label at the top. I wonder if we can get that a little bit more in focus. I want to have a label at the top, then I want to have a big number, and then these buttons here, if it is going to work. Say display, this is a toggle button that switches between displaying the multimeter. So at the moment this is just showing a counter, but if we switch to there, then this is actually showing the multimeter. And then we can also, just for the sake of it, toggle the counter on and off. So we've paused the counter. You can reset the counter. So once again, none of the actual counting functionality or anything else is happening on the Android. It's all happening on the Arduino. So if I disconnected this, the counter is still running in the background, and then it'll just update when I connect back. Then, of course, everything needs a toggling LED. So we have an LED connected as well, which will turn on if it's actually on screen, which is not quite. So we can also toggle the state of this LED here. And so for the multimeter functionality, we switch it into multimeter mode. And then if you're familiar with how the Arduino board is laid out, you'll know that we have power supply headers on it. So we can just connect to ground. And it shows us that 0 volts. It can connect to 5 volts. Tells us that there's 5 volts there. And we can connect it to the 3.3 supply, and it tells us that it's roughly 3.3. So not a particularly functional tool, but enough to kind of show you that you can sort of have relatively sophisticated interfaces even with a small number of different types of widgets. And then I disconnect the phone, then it will come up and say, hey, I need to have an Android handbag device connected to me, so please do. So that's the multimeter. And then we also have, so again, this is using the SparkFun USB host shield, and then just a standard Arduino Uno on the underneath side. There's also, again, SparkFun's got a thing that has, essentially is like the Arduino Mega, that has the Mega and USB host functionality on one board.
10 minutes.
Cool. So the next demo is an LCD scroller. So another example where this situation is, or where this technology is useful, is you might have a device that's sitting out somewhere, and every now and again it needs some configuration, but you really don't want to have things being configured with a permanent user interface on the device itself. So you can go, okay, my phone is going to be my user interface, and that way I don't have to have buttons and extra screens and stuff on my device. So this will just sit there and scroll happily. And we go, okay, well, we really need to update this message. So we connect our phone, and hopefully it will focus. Any day now. I don't know why it's suddenly decided that that's the... Okay, anyway, so the big button at the top says scrolling on off, and you'll notice in the background it's still scrolling there. So we can turn the scrolling off, and that'll pause the scrolling, so it's sort of no longer blurry in that corner. Wow, that's really terrible. And then it also has a text box that we can change the message on. So we can just use the standard keyboard, change the message. And start the scrolling back up and confused by something, that's for sure. Sorry? Oh, yeah. I might need to restart cheese. Ah, cool, cheers, thank you. Hey. F11. Yeah, so we've now modified it and then disconnected the phone and now it's back scrolling. And so the message is also stored in EEPROM, so it'll be maintained through power on and off. Now, you may be going, well, that's all very good, but what happens if I have a really long message that I want to be scrolling through or displaying on an LCD screen? So I've got a solution for that as well. Here we have another LCD. And so you're like, okay, well, how about, can I store my messages on an SD card and then be able to have them stored on that so I don't have to enter in a new message, but I want to be able to change the message as well? To which I say yes, because the USB Droid, which is this board underneath from Freetronics, has both the USB host functionality and the SD card functionality on it as well. So we can actually, again, every time when I'm connecting there's no separate application. It's just one application that then has all these different user interfaces. And so I can plug this in. And the new user interface with that is a sophisticated display manager app. So when I hit next message, it will search through the SD card for a message file which ends in .msg. And the text of the message is hello world, and I don't want to type that multiple times, so we just click the update display button, and now our hello world is without punctuation. It's a little hard to see the difference, so we'll look for another file. So again, this is going through the SD card, looking for .msg files, and then showing you the content of them. And then updating it. So, okay, here's my promotional file. I want to change the sign to say that. So we hit the update display, and it changes to handbag, which has been read off. So you could have any file on your disk which you read from. So obviously, if you have a more sophisticated piece of functionality, the fact that you can use your phone to configure it, but all the configuration is kept on an SD card, it gives you a lot of flexibility in how you configure these things. So you're obviously by now convinced that you want to play some with handbag, and you want to see how easy it is to actually write a handbag sketch. So we've got a case study which is toggling the state of a LED. So this will be the app that we want the user interface to have, basically a button and then some text. So everything starts at the action callback. So this is what's going to get called when you press the button. So in this, it's simply saying, okay, digital pin 3, we want to turn it on, and then we want to turn it off if it's on. So then you set up the user interface like this. So you have an object which is permanently there called handbag, so it's just like cereal or something like that. And you say add a label, and then you have the text of your label. And then if you have a button, then you supply the text of the button and then also a callback that will be called when you press the button. So it's like JavaScript. You would have like an on-click handler or something like that. It's the same sort of concept. And if need be, you can actually alter the text and the functionality, or the text later on, so you can say set the text of the button to be something else, or set the label to be something else, which is like what the multimeter demo was constantly updating the value of the label. A question?
How do you refer to it if you haven't given it a label?
Yeah, so basically the question was how do you refer to the widget after you've added it? Basically when you do the add functionality, it returns a widget ID, which I'm not using in this situation. Then there's some boilerplate, which is used to initialize the handbag and Android accessory libraries. There's a bunch of additional functionality that you can have happen automatically, but we'll skip that at the moment. And then you just have to have setup. So you provide setup with the user interface. So that means that every time you connect your phone to the Arduino board, it will upload the user interface and display it. And then you have a loop which just has to go through and say, hey, what's happening on the USB. If there's something that needs to happen, you can do it. So in this case, the toggling is all happening when you press the button. It sends a message saying, hey, button was pressed. What do I have to do now? And then the Arduino will toggle the state of the button. If you wanted it to do something else, so like in the scroller demo, while it's sitting in the loop, it's scrolling as well. But it's not waiting for something to happen on USB. So that gives you the flexibility of things. So that's the most straightforward way to get started. You can see just from these examples, even having the ability to have text edit, label and buttons give you quite a bit of flexibility in terms of functionality for a user interface. So the only other question is, what do you want to make your phone or tablet do today? So all of this is open, licensed under an open source or free software license. It's up on GitHub. If you go to handbagdevices.com, it will take you to a page which lists sort of how you can get started with this. And you can follow the project logs on that on my site, Labradoc. So, any questions? I see one there.
Just under the covers, are you actually generating a unique app every time you do a sketch for the Android app, or do you have like a wrapper? Because I know there's the Android processing project that lets you create Android apps from processing.
No. So the way that it works is you have one app that's installed on the phone, which is essentially a shell, and it knows how to receive a user interface definition, and it knows how to send back messages to the Arduino to say a button has been pressed.
Didn't you also have a bit of code that ran? Oh, sorry. Didn't you also have that little bit of code that when you press the button, it was sending, it was doing a function call or method call to tell the Arduino to do something?
Yes. So that's all built into one application. So the Android app essentially has no knowledge. All it knows is display the user interface and then send back whatever someone is doing to the user interface back to the Arduino. So yeah, the app itself doesn't actually get updated. So that means that you can walk up to any phone, install the handbag app, and then install any handbag compatible accessory, and it will work on that device straight away with no further configuration.
Do you have a graphing or plotting widget?
Sorry?
Do you have a graphing or plotting widget?
No, currently we don't have a graphing or plotting widget. I have considered it. On the feature front, there's been a lot of things that I've considered implementing, but thought I'd better focus on like documentation and stuff first. I know, it's weird. Patch is gratefully accepted.
What sort of state on the Android device is available to your your Arduino through Handbag, can you access GPS and all of that sort of stuff?
In theory, yes, you can access, and that's where I'd like to get to. But at the moment, it's all one way. One of the issues is that if you have an application that requires like permissions to access that functionality, it means that any accessory that you connect has that permission as well. So it's kind of like if you install one accessory that you want to give access to, say, GPS, then in theory any accessory can have access to it. So that's sort of one of the questions about looking at solving. But yeah, certainly there's no reason why you can't say send back a GPS position or accelerometer position. You just have to write the code. Anything else? One down here.
In its current state, then, what's the current level of complexity of the user interface? What sort of widgets, nested menus, functions, etc., that you can do with it? Do you have an example?
Right. So basically, what you've seen here is like the full extent of what's available at the moment. So you've got labels, which you can modify. So essentially, that can work as a display. You've got buttons, and you've got a text input area, which allows you to retrieve some sort of input from the user. So you may think, okay, that's a fairly limited range, but like even just with what I've shown you here, that still gives you quite a bit of flexibility. And again, it's kind of trying to strike that balance between like sort of adding features and getting it so that people can use it as easily out of the box as possible. But there's no reason why you couldn't sort of add some additional functionality and just sort of extend the range of widgets that it's got. So there's sort of some measure of the Handbag app can tell what version of the library is running. So if there's a change down the line, then it can say, hey, it's time to update your Handbag app to support whatever this new feature is.
So does the Handbag app provide any facilities for uploading files from a Arduino device? At
the moment, no. I did actually briefly look into whether or not you could actually have the Arduino upload a full app as well, and discovered that you can get apps down to about 2 or 3K. So yeah, like in theory, it would be possible to say upload an APK file, write it to the SD card, and then install it from that. But that's left as an exercise for the viewer.
As a question, are there any provisions for sort of converting a Handbag app to a possible sort of retailable or sellable Android app itself?
No, at the moment. I mean, you could. I mean, essentially, it's kind of the idea is that if you were wanting to like make money from it, then you would be selling the accessory, and the app would kind of come along as free.
I'm also thinking in terms of is there like a library or something to embed it within a, say you've got a music app and you make a remote or something, can you embed that as a library for other applications to use?
Oh, right. At the moment, no, but there's no reason why you couldn't have that running as a service in the background. So actually, that was something I didn't mention with the, so the Nexus 1 dual display isn't written using Handbag, but it runs as a service in the background. So you could, in theory, have multiple apps send, say, intents to the service and say, hey, I want to display this on the screen. So you could potentially, if you had a Handbag service running, then you could just say, hey, what message is being sent. But yeah, at the moment, it's monolithic, so you can't just kind of pull it into an existing app.
Any more questions? Yep.
Do you want to try an ice cream sandwich?
Sure. Have you installed it?
Yes.
Cool. Yeah, one of the amazing things was when I was at sort of a function, and someone had from HTC had one of these one of the flyers, and I installed the app and hadn't tested it with it before, and yeah, it worked out of the box first time, which is like that doesn't even happen when you're doing a demo with something you planned. Let's try this one, I guess.
That was my question.
So you've got handbag installed?
Yes.
Cool. Are we going to take bets? I like your confidence. Okay, so it's popping up and says, do you want to use this thing? And the only catch is sometimes the first time it runs, it doesn't quite react fast enough. So we'll try that. And okay, let's try resetting this. So apparently the answer is no.
But it will lend you his phone for a while.
Yeah.
No.
Have you tried Honeycomb?
No. Yes, because I think that was what the flyer was running. Thank you for that. Obviously, further development is needed.
The Zoom.
Cool. Yeah.
Handbags on Honeycomb, right?
Well, we can check that out later. Yep.
Okay, we're now finished, so let's thank Philip for a very interesting talk.
Cool. Yeah, come find me later, or we'll mostly hang out at the Arduino.